We're doing C++, pointer to a pointer to a pointer. I did C++ in college. That was the first programming language I learned, and I haven't done it since then. But I understand people are still doing C++, and so for that, I'd like to welcome Julia Reed. Julia, welcome to the VS Code live stream.
Thanks, Burke. Happy to be here.
So what is it that you do with C++ at Microsoft?
Good question. So I'm on the Visual C++ team at Microsoft, which covers a whole bunch of C++ developer tools, not just VS Code. We also work on Visual Studio and the Microsoft C++ compiler, but I focus specifically on C++ development experiences in VS Code. And my team actually maintains 3 extensions just for C++ development in VS Code. We have the C++ extension, which gives you IntelliSense and code navigation and debugging for C++ files. We have the CMake Tools extension, which is for building and debugging CMake projects, and the Makefile Tools extension, which is for building and debugging Makefile projects. So I'm going to talk about all 3 of those today.
Well, that is exciting. I'm going to be honest. I only knew what one of those things was, but we do have we always get chat is always like, hey, can y'all do more C++? And chat, you may recognize Julia if you watch our YouTube shorts. You've made a couple of those for us, TikToks and shorts. Yeah. So take it away, Julia.
Cool. All right. Let me share my screen.
There we go. Let me add it here.
Okay.
And let's change there we go. Look at that. Man, StreamYard's such a nice tool. Everybody use StreamYard. It's great. We love it.
Nice. Okay. Can you see my terminal?
We can.
Perfect. So yeah, before actually diving into the first demo, one really important concept to understand about the C++ extension in VS Code is that it doesn't come with the C++ compiler. It doesn't install one for you. It uses whichever C++ compiler you have installed on your machine to set up IntelliSense and debug configurations for your project. So the first step for C++ development in VS Code is making sure that you have a C++ compiler already installed on your machine. So for the demos today, I'll be using a MacBook. So I'm on macOS. But the experiences are the same across Mac, Linux, and Windows, and I'll be sure to call out any platform-specific instructions if we run into any.
So, Julia, do both Windows and Mac come with a C++ compiler already installed?
Mac does, most likely, because Xcode comes with the Clang compiler, and you can verify that just by running clang -- version. And if it doesn't come installed, then you can use the Xcode select command -- install, and then that'll install it for you. So this is if you're on Mac. For Windows, you'll have to install, well, if you have Visual Studio installed, then you'll have the Microsoft C++ compiler. If you don't have Visual Studio installed, then you'll need to install it. And you can check out our docs to do that. So for Windows, we have a document for installing the Microsoft C++ compiler and how to use that with VS Code. Quick note that you are allowed to use the MSVC compiler with VS Code as long as you have a valid Visual Studio license, either Community, Pro, or Enterprise. But if you want to install GCC on Windows instead, then we also have tutorials for that. You can do GCC with WSL or with MinGW through MSys2. And we also have a tutorial for installing GCC on Linux.
And so for those of us who don't know what like GCC is or MinSys or whatever, these are all compilers, I assume, for C++?
Yeah. So the most popular compilers for C++ development, I'd say, are GCC if you're on Linux, Clang if you're on Mac, and then the Microsoft C++ compiler if you're on Windows. And then MinGW is a way to use the GCC compiler and Linux tools on Windows. But WSL is another way to do that. And if you're using VS Code, I'd recommend just using the WSL extension. It's a pretty seamless experience.
Nice. Okay, thank you.
No problem. Okay, so now that we've covered installing compilers, if you have a C++ compiler installed, then you're all ready to start C++ development in VS Code. I think the easiest way to open your project in VS Code is just to navigate to the project directory in the terminal and then type code space period enter, and this opens your project in VS Code. So for the first scenario that I'm going to talk about today, it's just a very basic run and debug a single C++ file in VS Code. So we have one source file, main.cpp, and this is just a simple Fibonacci program. It prints out 15 terms of a Fibonacci sequence. I don't have any like third-party libraries or anything. So all I need to get IntelliSense and to run and debug this file, all I need is a C++ extension, which you can install in the extensions marketplace directly from VS Code.
So, Julia, real quick, you mentioned that there's IntelliSense for C++.
Yeah.
But Ethan is saying he'd like to know why there's no robust code completion for C and C++ like there is for Java and other high-level languages. Does that mean that there's not the same kind of IntelliSense? I'm not sure what he's referring to there.
We have code completion with IntelliSense, which I can just give you a quick example. Like if I start typing N, then we do have autocomplete lists. What Ethan might be referring to is IntelliCode versus IntelliSense. So IntelliCode is an AI-based IntelliSense, and that's what we have in Visual Studio, I believe. And there are some languages in VS Code that use IntelliCode instead of IntelliSense. The C++ extension uses IntelliSense. And there are discussions around maybe switching to IntelliCode, but for right now, it's IntelliSense. But we do have autocomplete.
Okay. Ethan, hopefully that answered your question. All right. Thank you, Julia.
No problem. Okay, so here in my main.cpp file, IntelliSense appears to be working right off the bat. We don't have any like red error squiggles under our include paths. And we have autocomplete, as I just showed you, quick info. So if I hover over a variable, I can see the type information, or documentation, signature help if I hover over a function name. And the IntelliSense should work out of the box. But if you need to customize your IntelliSense configuration, maybe you're including third-party libraries in your project and you want to make sure the C++ extension can find those libraries, you can do that by clicking on this button in the bottom right of the status bar. So if you hover over it, it says C/C++ configuration. And since I'm on my MacBook, it's telling me that I'm using a Mac IntelliSense configuration. Let's click on that. And here we can edit our configuration either with a UI or by editing a JSON file directly. But let's use the UI. Okay, let me zoom out a bit so we can see all these.
Are the configurations different between Mac and Windows? Like I always thought that was strange that there's like it says the name of your computer in the status bar.
Right. So the reason that the C++ extension will come up with a default IntelliSense configuration based on the information it detects about your system, such as your operating system, your architecture, the compilers that are found on your machine. But a lot of C++ developers target multiple platforms or architectures in their development workflows. So the point of having like different IntelliSense configurations for a project is so that you can create platform-specific IntelliSense configurations.
Okay.
Yeah. Or so that you can have one configuration that uses Clang and another configuration that uses GCC if you want to test your code with both of those compilers. So here, this is just the default configuration it created for me, and it called it Mac. But I could create a new one and call it Linux or custom configuration or whatever. And then within that configuration, you can choose which compiler you want to use. So this is a list of all the compilers found on my machine by the C++ extension.
It looks like you've installed them all.
I've installed them all. And then compiler args. So when you are compiling your program from the command line, if there are any special args that you're passing to the compiler, you can define those args in this compiler args property. And then when we query the compiler to set up IntelliSense for your project, we'll query it with those args. So if you are using any special compiler flags, you'd define them here. IntelliSense mode tells us which platform and architecture variant of the compiler to use. So this is really helpful if you are setting up cross-compilation IntelliSense configurations. So let's say you are on your Mac laptop, but you're working on a project that is targeting Linux ARM with GCC. As long as you have that GCC compiler installed on your system that's able to compile for that architecture, then you can point your IntelliSense configuration to that compiler and then change your IntelliSense mode to Linux GCC ARM. If you want to learn more about setting up cross-compilation IntelliSense configurations, we do have a tutorial with the rest of our docs. It's called IntelliSense for cross-compiling.
This is a lot of configuration, Julia. Like, do I have to do these things to get started with C++ and VS Code, or?
That's a good question. You shouldn't have to. And like when I opened this file in VS Code for the first time on Mac, like the default configuration that the C++ extension created for me works. But I like to show how the IntelliSense configurations work under the hood, because as you progress in C++ development, you're likely going to want to customize your IntelliSense configuration. I think like one interesting thing about C++ is that there are a lot of different tool chains out there that people can be using. You know, it's like a lot of people use Clang, a lot of people use GCC, a lot of people use MSVC. There's not like one overruling compiler. And so being able to customize those configurations is great, so that if you and your teammate are using different tool chains, you can have configurations for both those tool chains in your CVP properties JSON file, which is what that UI I just showed. It writes to this file. And that way you can just toggle between those IntelliSense configurations.
This low-level stuff is so interesting because JavaScript and Python developers, this is like not something we have to think about, right? Like you just write JavaScript and it runs in all places. We got a couple, well, we have actually a bunch of questions coming on in the chat here. I think this is Sobi. I hope I said that right. If I butcher your name, I'm doing the best I can. I'm sorry. I do apologize, genuinely. Can I use language servers like CCLS in VS Code?
So we have when you're using the C++ extension, you're using the Microsoft C++ language server. If there are other C++ language servers that you want to use, you can check out to see if there are other extensions that support those, as long as those language servers are using the language server protocol. But for the C++ extension, it's just our language server.
Interesting. And Animerge here, that's an interest. That sounds like a gaming tag. Maybe I'll steal that from my Overwatch account. So sometimes I hope there's an extension that can do magic with my CMake files and the properties.json, which just sync the external dependencies I'm using. Again, I have no idea what this means. Do you know what they're referring to here?
Yes, and I'll be showing that today, actually.
Okay. All right.
The extension is magical.
All right. I'll get out of your way. Proceed.
Okay. So before diving into CMake Tools, I just want to quickly show you how you would run and debug a single file project, like if you're not using a build system. So you would set a breakpoint and then just select run, start debugging, or you can hit F5. And then you're going to want to choose your environment and the compiler that you want to use to build your program. So this, again, is a list of compilers found on my machine. And I'll select Clang. And then let me zoom in a little bit. Okay. So in the terminal, I can see the build finished successfully and it launched the debugger, which is what we're looking at right now. And within this debug UI, you can look at your local variables. You can change the values of your variables by doing control-click, set value. You can add variables to watch, step through the program, and you can even look at the assembly language in disassembly view by opening up disassembly view during a debug session. And then if you continue running the program, then your output will show up in the debug console if you're on macOS. So you might have noticed that a JSON file popped up right before the debugger launched. And that's because when you hit F5 or select run start debugging, then the VS Code will create these two files, tasks.json and launch.json, in the .vs Code folder for your project. And tasks.json stores your build task. So it tells the C++ extension how to build your program. So remember how I selected Clang++ in that little dropdown? So the build task that was created is using the Clang++ compiler. And then the args property tells us which arguments to pass to Clang to compile your program, such as the file name, the output file. And you can define as many build tasks as you'd like for a project. And then whichever one has this is default true property is the one that'll run if you just do Command-Shift-B. So you can think of, like, if you're normally compiling from the terminal and you write out Clang++ and then a bunch of args, you can turn that command line into a build task in tasks.json so that you don't have to keep opening a terminal and typing out that command line every time you want to build your program. You just run Command-Shift-B. So now that this build task is created, if I go to my source file and hit Command-Shift-B, then it'll run the build, and you can see exactly what the command line looks like that it's constructing from that build task. Launch.json is the same idea, except it's for your debug configuration. So you have the name of your program. If you need to pass any args to your program on the command line, you can put those in this args array. And you can also define args to pass to GDB specifically, or to the debugger.
So would a correct summary be that the tasks is where you define how to build it, and the launch is where you say, okay, run the build, and then execute the built program and attach the debugger?
Yeah, exactly. So the task is how you build. The launch configuration is how you debug. And then you can define a pre-launch task, which is the build task, so that if you run this debug configuration, it'll verify, like, oh, I'm going to build, and the build has to be successful, and then I'll launch the debugger.
And we set all this up for people, right? Like, we don't make them do this themselves.
No. So as you just saw, like, I didn't have these two files before. I just set a breakpoint, hit run and start debugging for the first time, and then the C++ extension created this build task and this debug configuration for me. And if it, like, hopefully it works right out of the box and you don't actually have to look at or touch task.json or launch.json. But if you have, arguments you need to pass to your program, or there are other compiler flags that you want to specify, you could do that in those JSON files.
So interesting question here from Ryan. What's up, Ryan? Is C++ with GUI programming possible with VS Code? Can you build GUIs with C++?
You can, totally. I would say it gets more complicated if you are doing remote development. You'll need to configure some additional settings in order to be able to see that GUI pop up. But it's totally possible. I have done some demos where we build Super Tux, which is a video game, using VS Code.
You built it? Did you say you made a video game?
Well, Super Tux is an open source video game. So I didn't write it, but in some of our demos, my team, when we're speaking at conferences and stuff, that's a project that we commonly use as an example, and that totally launches a GUI. It launches a video game.
So one more question here, and I think this was answered in the chat, but Pro Doge, Which interesting avatar. It looks like you spent some time on that or you downloaded it off the internet. I don't know one or the other, but asking, I couldn't get include bits standard C++.h header to work on my Mac. Can you show how to use it? That seems like a relatively specific question about a specific include.
It is. I'll just say that if you are using a system header or a standard library or a header within your project directory, you shouldn't have to configure any additional settings. Like those should just work. If you are using a third-party library, then in your IntelliSense configuration, in the include path property, you can put the path to that directory. So for example, like on this laptop, I use VC Package to install third-party libraries. So I have a path to all of the libraries I've installed with VC Package in my include path, so that if I were to include those files or those header files, IntelliSense would be able to find them.
Gotcha. Makes sense.
Yeah.
Hopefully that answers your question. I don't know that we can guarantee the working of every header file, but
Right. If you think there's a bug, definitely open an issue on the CMake Tools repository. I want to quickly show, before we run out of time, I want to show the CMake Tools extension.
Yeah, go ahead.
Okay, cool. So most people with who are developing with C++ are probably using a build system, and CMake is a really popular cross-platform build system. You can install the CMake Tools extension in the extension marketplace in VS Code directly. And this program I have here is also a Fibonacci program, but it's using some third-party libraries, which I've installed using a VC package manifest file, and it's using CMake to build my project. Because I have this CMake list.txt file in the root of my project directory, the CMake Tools extension is activated, which I can tell based on the buttons that it's providing in the status bar. You'll also notice that this file or this project is using CMake presets. For those of you who are using CMake, you may be familiar with CMake presets. CMake presets.json is a file that Kitware started supporting earlier this year, and it enables you to share common configure, build, and test options with teammates because you can check it into source. So any options that you normally pass to CMake on the command line when you're configuring, building, or testing your project, you can just define those in this JSON file and then use this file to invoke those same CMake builds from the command line in a CI pipeline or in VS Code or Visual Studio. Anyway, so you have your CMake presets file, and the CMake Tools extension will detect that file and read from it and then surface those presets in the UI. And you can do that. You can choose presets by clicking these buttons in the status bar. So this one is my configure preset, and it's showing me macOS because I'm on macOS. I have a Linux configure preset also defined, but that's irrelevant, so it's not giving me that option. And then once you select your preset, then you can configure your project. Okay, and the configure succeeded. And then we can select our build preset. So I'll do the verbose build and build target. We'll do all, and then hit this build button in the status bar, and the build succeeded. So now to debug our program, let's set a breakpoint and select a launch target and this debug button, and this launches the debugger. So I'll just continue running the program and exit the debug session. So if you're using CMake presets, which is not a VS Code specific thing, it's supported by Kitware itself and any other editor or IDE that enables support for CMake presets, then you can configure, build, and debug and test your program in VS Code without configuring any additional like VS Code specific settings, all just within a few minutes. It's super easy. And I mentioned that you can also test your program using ctest. So in this project, I do have some tests defined, and I'm using gtest, and I have a test preset. So I can select that test preset and then hit this button in the bottom right to run the tests, and it tells me that they've succeeded. And let me zoom out so you can really see all those buttons. If you hate the status bar buttons, if it's too crowded, then you can disable the CMake Tools extensions buttons from the status bar and instead use the CMake pane here on the left. And you can just do the same things from here. You control click and you can build, debug your targets. So that's the CMake Tools extension in like a 3-minute demo. But if you want to learn more about CMake Tools, you can check out our docs. Or if you want to learn more about CMake presets, Erica, one of our coworkers, gave a really great talk at ACCU 2021 called Cross-Platform Pitfalls and How to Avoid Them. And she talks about CMake presets and CMake Tools.
So that's I've got the AKA for CMake presets demo up.
Perfect.
You can check that out. And then Makefile tools, is that the other one?
Yes. So I know I'm kind of over time here, but I'll just quickly show you without diving into all of the settings. But I have a Makefile project open in VS Code, and the project I have open is Vim, which I'm sure many of you are familiar with. Once again, install Makefile Tools extension.
Never heard of it.
And here you can go, once you have the Makefile Tools extension installed, you'll see the Makefile Tools icon, which is the C++ file with a little gear. And on the left, click on that. And then here you can choose how to configure your project. So I'm just using the default configuration, but if you need to pass any special flags to configure your project, you can define additional configurations in the extension settings. And then let's configure the project. So you can just type Makefile configure from the command palette. And then let's select a build target. So this is a list of targets found in your project's Makefile. So Makefile Tools extension will read from the Makefile and surface all of those targets in the UI. Let's select all and then hit this build button. And it says target all built successfully. And then the last thing is to select a launch target. And then when I selected that launch target, the Makefile Tools extension actually created like a launch configuration object in my settings.json. So this is where if you need to pass any command line args to your program when running and debugging it, you can specify those in binary args. You can also define other debugger settings here, like stop at entry to be true if you want the debugger to stop as soon as you hit the main method. And then if we go back to our Makefile Tools pane, let's run the program. You can see Vim in the terminal, so that worked. And then if you were to debug.
Wow, that's the fastest exiting of Vim in history. Did you see that? The land speed record.
And then, yeah, you can launch the debugger also using that debug button in the icon. Or
so
in the
interesting question here from Sci-Fi Not. It just says VS Code C++ is not supposed for M1 Max. I think there's some words missing from that comment, but doesn't work on M1? Is there something people need to know?
IntelliSense, or we do have some support for M1 Max. I believe we have IntelliSense support, but not like default debug support. But there is a way to configure debugging on M1 Max, though I believe it requires using an emulator. Having native debug support on M1 Max is definitely on our radar and something that we'll hopefully get to implementing soon. In the meantime, there is a way to configure your launch.json so that it works. I will take some time to find that, and then I can post that on Twitter or like on a blog post or something so that people are aware of that.
And Luis here said, I did compile C++ last night in my M1 Mac with IntelliSense confirmed. So maybe. Yeah. Thank you, Luis. It's working. All right, let's see here. Just looking at the chat. There's so many questions, Julia. There's so much going on over here. This was interesting, not related to C++, but is this the first stream? No, this is like the 40 something stream, but we stream. And then I think the same person asked if we have a stream schedule. We do. It's every Thursday at what time is it? 8 a.m. Pacific time. Are you on the West Coast, Julia?
I am actually in New York, so
Oh,
lunchtime for me.
It's a very convenient time for you. Yes,
I know.
I always think it's funny when our West Coast people have to hop on at 8 a.m.
I know. I actually had time to drink my coffee.
That's what you get for living on the West Coast. Nobody feels sorry for you. All right, chat. We're 1 minute over. If you got any questions for Julia, we'll hang on for one more minute here. I guess we can take this question. I don't have the this person asked. This is Hamadreza. How do I compile VS Code from source on Windows?
That is a good question. If you go to the VS Code GitHub repository, they might have some instructions there.
Okay, that's
all I have. Sorry.
Yeah, I think it's probably in the README. No, it's a great question. So yeah, that's it. Lots more in the comments. Hey, chat, everybody say thank you to Alessandro, who's been answering your questions from the VS Code channel there. Thank you, Alessandro, so much for your help. Thank you, Julia, for being with us at 11 a.m. Eastern time. It is lunchtime. With that, we will see you next week. Next week, I believe, is our release party for our last release. Producer Alessandro, am I correct on that? Can you drop that in the chat and let me know? Because if it is, we have something special to show y'all, not related to VS Code, like an actual physical thing we want to show you. So we'd love for you to be here. All right. Thanks, everybody. We will see you back here next week, Thursday, for the VS Code live stream. Bye, Julia.
Thank you.
Bye, chat. See ya.